Hi, everyone. I want to just talk a little bit today about the why and how of graphing and really why we're doing this experiment then today. So the why is relatively simple. It's sort of an easy way to visually see a set of data instead of looking at individual numbers that it's hard to make sense of the overall trend of data. So you've heard of the saying, a picture's worth 1,000 words. Well, that's what a graph is. You can just quickly get a picture of what the overall trend of data is without having to look at each number and construct it and make sense of it in your head. So then the how is what I'll get to next. So to show you this, let's look at a set of data. So what I've done is I'm going to go ahead and share my screen here. And so what I've done is I've gone here to, this is the US Geological Survey's, a set of data that I found on their website of the relationship between temperature of water and density of water. So I don't know if you know this, but colder water is actually denser or heavier. Denser is the same amount of water would actually weigh a little bit more. So colder water sinks down, hotter water rises up, and that's sort of the same thing with air or most fluids. So in general, that's the case, but density data is a little bit of a weird trend with liquid water. So you can look at this chart and you can sort of see some things at a cold temperature like 0 degrees Celsius. It starts out at 0.99987 grams per cubic centimeter. Then you go up a little warmer and it's right at 1 gram per cubic centimeter. Then actually at a little bit above 4 degrees, it's back down to 0.999. So actually it got a little higher. Now it's getting a little lower, etc. And you can see as it gets much warmer water, like 60 degrees Celsius, it's down to 0.98338, etc. Now you can see that data, make sense of the trend, but it would look a lot nicer if it were on a graph. So let's see what I mean. So the first thing is there's two ways you can do a graph. You can plot it by hand or you can use spreadsheet software. So I'll start plotting this by hand. It's going to be super painful because I'm doing it on a computer that's not a that is not a touchscreen. So this is sort of your really most painful way you could possibly do this. And because it's so painful, I've already actually gotten a little bit started. I'm doing this right now in Microsoft Word. There are some online tools you could do to do this on your computer. If you're going to do it, what I did in Word is I first put in this grid. It's actually a table, insert a table with equally sized cells, a whole bunch of them. Then I put graph titles on there, like density on this axis and temperature on this axis. And then I just put in a text box here to label the axes. This would be 0 degrees Celsius, 10 degrees Celsius, 20, etc. And I would need to do the density axis. Now for this, it's probably going to be super painful. So to decide how to label your axis, you need to just look at the overall range of data. My axis labels need to range from somewhere in the 1 gram per cubic centimeter range down to the 0.995 grams per cubic centimeter range. So I could do something like this. It's really up to you exactly how you do this. But you might, if you're doing this on the computer like I am, you might insert a text box somewhere and then go ahead and type in the highest value you want to put in, 1.00. And so that was kind of, oh, that works fine. And then I don't like these. I usually go to format and I take away the line on the outside of the text box. So I would do like no outline. So it's just the number. I prefer it that way. And that would be like the highest value. So I'd put that somewhere up here near the top. And then the lowest value that I want, now you can just actually copy, Control B or right click copy and paste. Oops. Maybe come down here and paste a bunch of those text boxes. So you can go ahead and drag those then to where you want them. So, and you can change the thing. So I said I want my lowest value to be somewhere around 0.95. Maybe that would be here. Then maybe I'd go up every 0.1. So 0.96. I drag that up here somewhere. 0.97. You want to be repeatable, so I'm going to go 0.95, 0.96, 0.97, 0.98. And 1. So I've gone up every 0.1. Now we got to make sure they're spread out evenly. So I've got 1, 2, 3, 4, 5, 6 of them. So it's really up to you. Maybe you go something like every 3 squares is another one. So if this one is the first line, then 1, 2, 3 is 0.96. 1, 2, 3 is 0.97. 1, 2, that's my place. 1, 2, 3 is 0.98. 1, 2, 3 is 0.99. 1, 2, 3 would be 1.00. So they're evenly spaced along the axis, not overlapping anything. Oops, that one wasn't. One more, something like that. And then I would go through and I would try to actually put my data on. So I'd grab a data point like this one. It's 4 degrees Celsius and it's 1.00. So at 4 degrees Celsius, I'm going to need a marker here. So I'm actually going to go ahead and start annotating in with Zoom, which is what I'm using right now. So I'll use this tool to go to right here. I've got 1 for the density and 4 degrees Celsius for the temperature. So I'll go to 4 degrees, which if this is 0 and that's 10, then 4 degrees is right shy of this line. So I'd follow that up and at 1. So this would be my first data point that I'm putting on the graph at 4 degrees Celsius and 1. Then you could go up and grab another data point. 10 degrees Celsius, it's 0.99975. So at 10 degrees Celsius, it's 0.99975. So that's actually also very, very close to 1. So that would still be somewhere right up very, very close to 1. You can see one where there's a distinction like 0.98870 at 48.9. So 48.9 is just shy of 50. We trace up to 0.9887, which would be somewhere up in this range right here. And then you could trace another one, maybe this one over here. So all the way out at 100 degrees Celsius, it's 0.95865. Which would be maybe about right in here. Something like that. So you can see this overall trend of data. You're already starting to get a picture of it slowly, of how the density of water changes over time. As it gets hotter, it gets less dense. Okay, so that's, like I said, that's like the most painful way you would be doing this. That's not really our preference here. So what we'd rather do, you do have to do that as part of your lab. That's one exercise, is making a hand plot. You don't have to do it in Microsoft Word like this. You can just draw it on a piece of paper. When you get there, it'll give you some details on that. There's also some ways online that you can do this if you didn't want to do it in Microsoft Word. Okay, but the best way to do it is in spreadsheet software. So this is really the best how of how to do graphing, is I've copied and pasted that data over here. Here's our temperatures in Celsius, and here's our densities in grams per cubic centimeter. So if you just highlight that data, you can come over here, and I'll try to slow down a bit because this is part that's really fast and easy. You can just highlight that data in Excel, come up here to insert, come find the chart that you want. When we're plotting two variables against each other, we call that an XY scatter plot. We're going to put X's, one set of data on the X-axis, one set on the Y-axis, and plot them against each other. And we almost always choose the one without lines connecting. So we choose this one here, and boom, all of that I was doing so painfully by hand is just on the chart in a second. And you can see quickly it gets a little more dense, and then the density drops off pretty sharply over as the temperature rises. One thing that you'll see here, there is a chart title, but the axes plots are not there. So you can either click on the axis and then right click, and you can format the axis and insert stuff. But in Excel, they actually have these quick layouts. So you can just hover over them and see what it's going to look like. This one looks fine. So you could choose that, or you could choose something like this. That would include a trend line, a linear trend line plotted to that data. I like this one, okay. And it's got the axes title. So then you could just click on those labels and type in that this is clearly temperature in degrees Celsius. And this is clearly density in grams over centimeters cubed. And that's pretty much it. That's the how. You can either do it by hand, which we will do in one of the activities as part of this lab, or in a spreadsheet software like this. If you don't have Microsoft Excel, there are some other options, and I've mentioned those when you get to there in the experiment. Thanks for watching.